And we're in chapter 3, where it talks about landforms. On page 88. Some changes on Earth take place gradually at rates of a few millimeters or less per year. Did you know some change is so slow you don't even notice it? Wait a minute, I think there's a picture that will help you understand that over here. Where is this? Let's see, what page is that on? Oh, I should have written down the page number. There, page 98. Now, I don't know how observant you are, but have you ever driven down the road and noticed telephone poles or fence posts tilting toward the road?
Yeah.
How many have noticed that? Rest of you haven't looked. Okay, now the rest of them, now that we've talked about it, what's going to happen? They're going to drive down the road and look for it. Okay, do any of you tell from the picture on page 98, can you tell why those telephone poles are tilting downhill?
Because the soil's tilted.
The soil is creeping downhill, but it's so slow you don't notice it. But because the soil is creeping, it's tilting the post. You can drive down, I think it's Gore Road in Raymore. Drive someplace around here where there's some fields and there are fence posts that are tilted almost that much, almost at a 45-degree angle, because here's this ditch that they've dug along the road to make the water drain away, but the field, it keeps creeping down toward the ditch and it keeps bending the fence post over. But you don't notice it. You think, why are those fence posts crooked? Because it's, and you can see the same thing happen with trees too sometimes, that they'll bend like that. But it's because what's happening is the changes are so slow that you don't notice what's happening. You just kind of see the results of it. And sometimes it is catastrophic. Let's see, what would be a catastrophic change in the Earth's surface that we've witnessed recently? That was reported on the news. It didn't happen in your backyard unless you live in Hawaii. Does anyone know what happened in Hawaii?
Volcanoes?
Didn't one of their volcanoes that they just think are just so cool because it attracts a lot of tourists decide that it was time to erupt big time?
I'm looking it up now.
What? You're looking it up now? Okay, and this thing erupted in such a catastrophic fashion that the stuff oozing out of the earth was going through neighborhoods. We're talking about some neighborhoods were buried in 23 feet of lava. And there was so much stuff coming out of the earth running down the hill, destroying everything in its path, that when it got to the ocean, it has now enlarged the island and made it bigger. In fact, there are some places out in the ocean where oceanic volcanoes erupt, and we don't notice it because there's no people around there, and then the next thing you know, some land comes bubbling up out of the water because the volcano is building up, and the whole chain of Hawaiian islands are really built on volcanoes erupting. So it's a little precarious living there, but it's part of what goes on in terms of studying. What are we studying here? Landforms. Landforms, because new land is being formed, and sometimes What's another catastrophe that you're reading about? I just read that there's an iceberg in Antarctica that's as big as Manhattan. Not Manhattan, Kansas. Manhattan on the East Coast. And it's about to break loose. And some people are alarmed because it's catastrophic. What's going to happen? Well, when it melts, they're saying it's going to raise the sea level maybe as much as a foot. I doubt if it's going to be that hard. You know, there's so many Chicken Littles who just keep saying the sky is falling, the sky is falling. But if you live on an island where the highest point in your island is only 6 inches above sea level, if the sea level rises 6 inches, what just happened to your front yard? It just became underwater. And the water's probably not going to go away, so you're either going to have to build your house on stilts and quit raising rice, or you're going to have to pack up and move. You go, but my ancestors have lived here for generations. Well, during past generations, there wasn't as much water. It looks like someone's going to have to move. I'm thinking it could be. Anybody have friends or relatives live in New Orleans? I'm thinking if the ocean waters rise. Have any of you seen pictures of people showing what's going to happen to New York City if we have a catastrophic increase in ocean levels? There's a whole bunch of New York Cities going to be underwater. Now, why are people in the Midwest not worried about that? We are far enough away from the ocean where the catastrophe isn't going to get to us. The people on the East Coast, they've got something to worry about. So sometimes it's very gradual and slow, and water levels rising have been gradual, but they can also be catastrophic. Probably hurricanes would be a water catastrophe because it brings so much salt water in to the land. And New Orleans, I don't know if you know this or not, but people who live in New Orleans know that they live on swampland that has pumps going constantly to pump the water out of it so they won't be walking through swamp. Well, if we have a big hurricane that brings a bunch of seawater in, it fills up the canals, it overloads the pump system, and everything gets flooded. And sometimes the pumps fail. So they do have some catastrophes there that they have to deal with. And some of it just has because the water just slowly rises. What did they just say recently? They just told the barges to quit going up the Missouri River to St. Joe. Why would St. Joe tell the barges that haul grain and coal and stuff to quit coming up the river? Anyone know what a barge does? Maybe you've never seen a barge up close. It's like one barge is the equivalent of about 12 or 15 railroad cars. And when they're pushing that thing up, okay, have you ever been at the lake when a big boat went by and caused, what do we call it, a wake? And if you're building a little sandcastle right next to the water edge and a big boat comes by and causes a big wake, you just experienced a catastrophe. The wake washed away. Well, see, a big barge going upstream on the Missouri River with the water so high because of the flood, then a barge is going to make it slosh over the edge and could cause one of the retaining walls that holds the river in to break. So they're saying no barges for a while till the water level decreases. The other, I guess you would call it catastrophe, would be when we have a drought and the water level is so low that they tell barges you can't come upstream because the water's not deep enough to support you. All it says here on page 88, in this chapter we're going to learn about the causes and rates of such movements and how they shape mountains, hills, and valleys. We look at Earth's rocks, soil, and surface landforms, which comprise the lithosphere, the outermost part of one of the four spheres. And it says, look back at figure 117. Well, let's just look up lithosphere. Let me turn this on for you. And let's just lithosphere. L-I-T-H-S-O-P. How do you spell that?
H-E-R.
L-I-T-H-O-S. L-I-T-H. There it is. Lithosphere. Definition. The rigid outer part of the earth consisting of the crust and the upper mantle. Well, let's see. Are there any pictures of it here? Lithosphere, National Geographic. I wonder what they say about it. There we go. So, what's the lithosphere? Can you see it there? The lithosphere is the crust. Can you see my little cursor moving around? And the uppermost solid mantle part. And it says this crust, that's water there. You know, on your little globe, all the place that's clear, that's where the water is. The land is the rest of it. So this little crust is anywhere from 0, I don't know where it would be 0, out in the ocean somewhere, where underneath it's constantly gurgling up, which is happening sometimes, we're just not aware of it, up to 100 kilometers. And you know how to translate kilometers to miles? 100 kilometers is like 60 miles. Have you ever noticed on your speedometer, if you're driving down the road, you're driving 60 miles an hour and it'll show about 100, it'll be on the same place about 100 kilometers. So just think about, so this crust is about 60 miles deep at its deepest part, which would be where this would be like the deepest part, and then at the thinnest part, it's not quite as deep. The crust and the uppermost mantle. So if we said, what was that hole that they were drilling you were talking about before class in Russia?
I don't remember what it was called.
But they drilled a hole down because they wanted to know what was down underneath here. So in Russia, they drilled a big deep hole. But if this is 60 miles deep at its deepest part, let's just say it's 30 miles. I think someplace I've read 27. If it's, let's just say it's 30 miles, let's say the crust was 30 miles deep, or even if it was 20 miles deep where they were drilling their hole in Russia. Oh, and then you see this picture down underneath here. How do I get that off of there so we can see the rest of this picture? There. You know what, when I saw this picture, I'm going, how do they know about all these different layers down inside the earth if they've only drilled a hole that's like 4 miles deep? Well, if they've never drilled down there, then is somebody just making this stuff up? Or do they have some way to measure this stuff?
I hope they have some way to measure this stuff.
Yeah, I would hope, because I mean, every place you look, when you look at the lithosphere, well, let's go back. And yeah, let's go down here to Wikipedia. Talks about the lithosphere, the outermost shell. On Earth, it's composed of the crust and a portion of the upper mantle that's elastic, on timescales of thousands of years or greater, the outermost shell of a rocky planet, the crust. And then there's that picture again. The lithosphere is subdivided into tectonic plates. The history of the concept of the lithosphere. So, this is not like somebody drilled a hole and pulled some stuff out and sampled it. This is just people theorizing as to what's down inside. But they do something to help substantiate their theories. They use seismographs. When you read this stuff, you find out, if you read all this stuff about it, you find out that they've got instruments that measure how fast seismic signals go through different kinds of material. And they conclude that if it goes through material on Earth this fast, then if it's going that fast through material under the crust of the Earth, then it must be similar material. You follow that? Well, when they say similar, I say, okay, I'll go with it similar in terms of its composition. But one guy said the reason they're drilling holes to check this out is it could be that it's a material that we've never seen before. It only has similar characteristics to the materials we have on Earth. You follow the rationale to that? So a lot of this stuff, understand, is people theorizing. It's people's theories about how this all came about. And does this surprise you that they think, okay, do any of you have a lava lamp at home? Those are so dumb. No, they're soothing, we say. I mean, what? There's a little bubble that floats to the top and cools off. And then when it cools off, it sinks back to the bottom. And there's a little heat lamp in the bottom. It gets it hot, so the little bubble comes back up again. And it comes up and cools off and goes down. And you just sit there and watch it and go, wow, how soothing. And I look at that and I'm going, that's soothing? Let's go bass fishing. Now that's soothing. But it's just different people have different things that are soothing to them. But here's there's a reason it's called a lava lamp. The theory is that the way that lava lamp works is the way it works, that down inside the Earth, way down inside, there's this little flow of stuff going up and down from the center of the Earth where it's the hottest. We just assume, the closer to the center you get, the hotter it is, and the closer to the surface, the more it cools off, so it comes up and goes down, and comes up and goes down, and you go, whoa. So the stuff under the crust of the Earth is going up and down like that lava lamp, and then the article I was reading said, well, no, it doesn't go that fast. It takes billions of years for the bubble to rise and fall. And I'm thinking, well, if it takes billions of years, the bubble hasn't risen yet because God only made the world a few thousand years ago. So this thing's going so slow, it's almost imperceptible to see it moving. But of course, their theory isn't it, that everything takes billions of years. So you just have to realize that's just the way these people think about things and talk about things. So there's some real good stuff to read in this article in terms of the theories. And I think I found something that might, let's see. Let's go up here and see if I can find this. CBC Geography. There it is, CBC Geography. Ah, I see my name down there. Do you see that? CBC Geography, Tom Bonine, Twitter. You haven't been there yet? Well, let's go there right now. Do I mean to switch apps?
Yes. Yes.
Okay.
I'm gonna show you my tweets.
Ah, different layers of the Earth, its interior structure and comparison. Well, let's listen to this guy from India. Is it turned on?
You have to push play. Push play.
Oh, I thought I did.
In this video, we're going to read about the structure of the Earth. Basically, this picture. This represents the interior of the Earth divided into different layers. So we're going to read about each one of them. The first layer is the crust. It is the outermost solid part of the Earth, basically this region over here. It is brittle in nature because during an earthquake, it is the crust that breaks easily, causing a fault. And we know that the density of material increases as we go more and more deep. Therefore, the materials which are available in the crust have low density. The thickness of the crust varies under the oceanic and continental areas. And this is obvious because ocean is like a cavity filled with water. If you remember Mariana Trench in the Pacific, it is the deepest known part of the world's oceans with a depth of 10,994 meters, almost 11 kilometers downwards. The mean thickness of oceanic crust is 5 kilometers, whereas that of the continental is around 30 kilometers. So if you drill on the ocean bed and you go 5 kilometers deep, probably you will touch the next layer of the Earth, which is the upper mantle. Similarly, if you drill on a continental crust, it will take around 30 kilometers to reach the upper mantle. Again, the thickness of the crust will be more near the areas of mountains, and you can figure out as to why. It is as much as 70 kilometers thick in the Himalayan region. Again, we know that Himalaya was formed due to the collision of plates. When two continental plates collide, it folds the rocks at the boundary, lifting it up and leading to formation of mountains and ranges. Therefore, the thickness of the crust in these regions will be naturally higher. The second layer is the mantle. This region over here is called as the mantle. So right from the end of the crust till the outer core is a region that is 2,900 kilometers thick. The upper portion of the mantle is called asthenosphere, but this region and the crust together is called lithosphere. Astheno means weak, and due to its weakness, the magma finds way to the surface during volcanic eruption. Now the total thickness of the crust and upper mantle, which is also known as the lithosphere, is 200 kilometers. The lower mantle extends beyond the asthenosphere and it is in solid state. This layer is also responsible for all of Earth's volcanic and seismic activity because 2,900 kilometer thickness is pretty spacious area for the formation of such natural catastrophes. Now laboratory experiments on rocks and minerals say that between 100 and 200 kilometers below the Earth's surface, the temperature of the rock is near the melting point. Therefore, molten rock erupted by some volcanoes originates in this region of the mantle. Remember this, the core of the Earth consists of nickel and iron, but here in the mantle, it is the molten rock that is
How do they
fluid
know
and can
that?
move. It is this fluidity that powers the movement of the tectonic plates of the Earth's crust. The third and the final layer is the core. Core comprises of the inner as well as outer core. Now moments back we have read the thickness of the mantle is 2,900 kilometers. So after that immediately the boundary of outer core will begin. The outer core is in liquid state while the inner core is in solid state. I've made a short video on this curious question.
How do
if
we
at all
know
you are
that?
interested in finding out the answer, head to the link in the description and find out. So the density of the material at the core is going to be the highest, and we have repeatedly read this that the density of materials increases as we go more and more deep inside the Earth. The core is made up of very heavy material, mostly constituted by nickel and iron. It is sometimes referred to as the knife layer. So Ni and Fe are abbreviations of nickel and iron. Remember this term knife layer. As we know that the Earth's core is divided into two layers, the outer and inner core. The outer core borders the Earth's mantle and is approximately 2,300 kilometers in thickness. The inner core has a thickness of 1,200 kilometers, giving the core a combined thickness of 3,500 kilometers. The outer core consists of nickel and iron in molten state, with a temperature range between 4,000 to 5,000 degrees Celsius. The inner core, on the other hand, is composed mostly of iron and has a temperature range between 5,000 to 7,000 degrees Celsius. And the inner core is mostly solid. This was all about the structure of the Earth, which I divided into separate layers, and hopefully you have gained some meaningful context regarding it. If you want to see more of such educational content,
Well,
make sure you subscribe. By doing so, you
if that went so fast
Thanks for watching, and I'll see you in the next
that you couldn't follow it, where do you go to find it, to watch it again later? CBC Geography. And there's some others in there too. Remember I told you about El Nino? If you're wondering from the last chapter when you read about that, there's a video on there, and it's not a guy from India talking. This is a guy from Britain. So you might be able to understand him a little better. But I clicked on another one where a guy in India was explaining it, and I thought, I don't think he's teaching in English. He's teaching in some Indian dialect. But sometimes I have trouble understanding people who speak English with a foreign accent, so it could just be my problem. But do you understand why I asked that question? I look at this stuff and I'm going, if we've only drilled a small little hole in the crust of the earth, how do we know about all that stuff down there? And they say, well, because we send, you know how we send radio waves out into space that measure stuff? They send radio waves down into the earth. Well, we can pretty well figure where the center is because we're shaped like a ball, right? So we can mathematically figure out where the center is, but in terms of what's there, and that's a solid and it's surrounded by liquid and it's iron, and what was the other one? Iron and nickel. Oh, but wait, when some of these eruptions occur and they spew out rocks, and guys collect some of the rocks that spewed out, and they find out that those rocks are mostly iron and nickel, what do they conclude? That it must be something from down inside the earth that broke loose and bubbled up and got spewed out by the volcano. So they have some stuff that they've collected that helps them support their theories, and we do have some ways of measuring things. But I got so frustrated because I Googled, how do we know this stuff, and nobody wants to tell me. They just want me to accept it and assume that this is the way it really is. But some of the guys who are arguing about we need to drill holes down there to get samples so we can, and here's what they said, so we can verify that the theories are right, or, this one guy said, we might learn that the theories are completely wrong. You weren't around, were you, when they sent those astronauts? And one of the guys complained about, we were on our way to drilling a hole down into the earth to check out what's down there, when President Kennedy got all carried away with sending people to the moon, so he took away all of our research money and gave it to NASA to send guys to the moon. You weren't here when those guys landed on the moon, were you? Well, I was watching it on television, if you can believe that. We all were. Here are these guys got in this spaceship and they flew to the moon, and they took a little taxi cab, a little Uber, and disengaged from their big rocket ship and went down to the moon and landed on it. And have you seen pictures of the footprint where the guy stepped on the moon and you saw his track in the dust? Any of you seen that picture anywhere? Okay, you know why that picture was so prominent? Here was the theory. If the Earth and the moon are billions of years old, trillions of years old, then over all these years, a lot of moon dust has accumulated. So it could be the dust will be so thick on the moon that when the little spacecraft lands, I mean, can you imagine landing a helicopter in a field where the dust is 100 feet thick and it just swirls up around you and buries you? So that was a concern that some of the theorists had. When they got there and they stepped out, it wasn't 10 feet thick, it wasn't 30 feet thick, it was only a few inches thick. So after that mission to the moon, did they revise their theories about how old the moon is? And how that the moon probably isn't as old as we thought it was, since it doesn't have more moon dust? No. They keep right on saying it's billions of years old. It's like, but what about only a couple of inches of moon dust? Well, it must have been the dust blew away. Because, see, they don't want to give up their theory, because why are they so attached to this theory of billions and billions of years? Well, when you read about it, it's just like, well, it took that long for all the chemicals to come together to go, whoop, we're alive. And then once the chemicals came alive, they go, well, let's not just sit here and do nothing, let's become something. And they, whoop, evolved into something that could swim in the water. Say, why water? Well, look at the Earth. 2/3 of it's water, so that makes sense. I mean, you follow the rationale? It's like, and then it's like, and then pretty soon some little critter in the ocean said, you know what? I think I'd rather live on land. And bloop, he evolved into some kind of little critter that could breathe outside of water. See, here's my theory. While the fish is developing lungs to breathe outside of the water, he drowns because he lives in the ocean. Or if the fish gets out of the water and lives on land until they develop lungs, they die because they don't have lungs yet. So can you see, the theorist says, well, it took billions of years for all this to happen. And I'm saying, well, that's your theory. But so when you look at this stuff, don't let the theory, I mean, go ahead and say, how do they know that? How do they know that? But I thought this guy, of all the presentations I found, this guy gave the best one of explaining the theory and how it all ties together. I mean, if you thought this one was a little too difficult to follow, I clicked on some that were the lithosphere for grade school children. Some of you going to be teachers might want to use it, but I'm telling you, the music they were playing for that, one guy was rapping the whole thing. This guy was saying a guy was doing it with rap music, and I thought, you know, that's wearing me out. So you can go click on anything you want and just look at other stuff out there, but this one gives a good clear picture of what's going on with the lithosphere. And page 89 talks about plate tectonics. Well, we might as well turn this back on and Google that one. Plate tectonics. Plate, T-E-C-T, plate tectonics. What do you want to look at? A map? Definition? Yeah, let's look at a map. Just because I like pictures. Oh, that's where they clumped them all together. Well, wasn't that cute? The edges of the continents seem to have a lot of similarity. So it's like these guys go, this used to all be one big mass of all. Can you see through that plastic how you could kind of fit some of those together? So it must have been at one time it was all clumped right together, and then it drifted apart with billions of years. Okay, let's assume it was all clumped together. When God said, "Let there be light," what appeared in the universe? The sun and the stars. And then he said he formed the earth, and then he formed the land. Now, do you understand? Could he have put all the land together and then just decided to separate it and spread it around the globe? You go, why would he do it that way? I don't know. God's ways are higher than ours, and we're probably not going to figure it out. And by the way, he doesn't tell us how he did it, so maybe he did that. Or maybe he just made them all separate, and in the process of making them, he just ended up with some of the sides of those looking like they might fit together. Who knows? Maybe he said, let's make them look like they fit together, just to see what people do with that when they discover it. I mean, you understand that we don't know the mind of God and what he did. You say, well, God wouldn't do something like that. He doesn't have a sense of humor. Well, you better read through the Bible and find out there's places where God does have a sense of humor. But just to show you this similarity between the sides of the continents. Okay, guess what? Have you ever seen a picture of a chicken embryo and a fish embryo and a human embryo? Okay, they're all very similar. So what does that conclude? That they all evolved from the same original little embryonic creature? Or they had the same creator who made similar embryonic forms for all these different species? Do you follow what I'm talking about? We don't know what happened. But man looks at it and guesses what's going on. Well, let's go back and find something else about tectonic plates. Videos of plate tectonics. Now that would be fun to watch those things spread out. There's some cool videos there. Let's go to Wikipedia again, see what they do with it. Plate tectonics. There it shows them all together. There it shows that picture of the earth that guy was talking about, the earth's crust. And it talks about the crust and all this stuff and the key principles, types of plate boundaries. That's the thing it talks about here on page 89. I think on page 89, there's one thing it talks about that I don't know if we need to discuss it, but do you know the difference between endogenic processes and exogenic processes? Endogenic processes are forces that cause movements beneath the earth, such as mountain building and earthquakes. And these internal mechanisms move portions of the earth's surface horizontally and vertically, raising some parts and lowering others. And exogenic processes are like erosion. So they're just geography words that label these different things that are going on. Have any of you seen pictures where an earthquake lifted part of a roadbed? Just Google earthquakes and you can see all kinds of cool pictures of earthquakes. And by the way, those guys in Russia who were drilling that hole down into the, hoping to drill through the crust of the earth, and they obviously got down, I don't know, it was a mile or two, and it got so hot that it was melting their drill bits and they couldn't go any further, so they gave it up. But some people say there really is no danger from drilling those holes. But have any of you heard about earthquakes in Oklahoma? Okay, I grew up in Oklahoma. And all of my life, all of my 18 years of growing up there, we never had an earthquake. And now, up in northeastern Oklahoma, they're having a whole bunch of earthquakes. So what's going on in northeastern Oklahoma now that didn't go on when I was an 18-year-old? Anyone know? Everyone in Oklahoma knows. It's called fracking. Anyone know what fracking is? It's a process that oil companies use to send chemicals underground to break up the oil so they can pump more oil out of the shale. But they don't tell you this, but when they use these chemicals to pump the oil out of the shale, then when they get the oil out, they separate the oil from the chemicals, but now they've got this chemical waste material that they have to do something with it. Well, you can't put it in a pond somewhere because it's too caustic, so guess what they do with it? They shove it back down in the ground in some empty oil well somewhere. And guess what's happened? Those chemicals are leaching down through the cracks in the crust, and they're hitting some of that hot, they're getting hot enough to where they're causing little explosions that are creating earthquakes all over northeastern Oklahoma. But why do the oil companies insist that fracking isn't causing these earthquakes? If the oil company said, yes, we agree, our fracking is causing earthquakes that broke your house, so we will pay for it. You understand? They don't want to pay for it, so they just don't want to admit that that's what's going on. But when you look at this plate tectonic stuff, I mean, do all of you know about the San Andreas Fault in California? Okay, the people in California have just been recently told by some scientists that it's been a long time since these two plates have pushed against each other so hard that they've broken loose and caused an earthquake. So guess what they're saying? It's been so long that when the next one happens, it's going to be huge. Now, if I lived in California, I would be checking to see how close my house is to the San Andreas Fault. And I'm thinking I would be putting a for sale sign in my yard and moving to a safer part of California. Say, I know what I'll do. I'll move to the seacoast. Oh yeah? Have you seen the latest pictures from the seacoast in California? All these big storms we're having have been eroding the seacoast. So people who built houses right on the edge, their houses are now falling over the edge and being washed away by the ocean. So, you understand? You can't get away from this stuff if you live close to the edge. We talked about the Boot Hill of Missouri. Down in southeastern Missouri, there was an earthquake in the early 1900s that was of such a magnitude that it made the Mississippi River flow backwards. The earthquake pushed the river. Now, if you take the Mississippi River and push it back upstream, what happens in St. Louis? It overflows its banks and you have a big flood. What happens when the earthquake subsides and all that water that was pushed upstream, plus the water coming downstream, starts rushing back downstream? Now your earthquake is followed with a flood. I'm thinking I'm not going to live in southeastern Missouri. Just going to stay away from there. And you know what the people in southeastern Missouri say? Yeah, where do you live? Well, I live in Kansas City. What, southeastern part? Yes, why? Well, you live in Tornado Alley. Yeah, well, I have a basement. And I have insurance that says if a tornado blows my house away, the insurance company will build me a new one. So it hasn't happened yet, but who knows? Maybe it will. So a lot of this stuff, you can Google it if you want to see pictures of it and see what it talks about. And those of you who are going to teach it, just Google this stuff and find out what's going on. And maybe look at, oh, there's some pictures on page 90 of what they look like. How long ago did they say? 200 million years ago? And then 135 million years, and 65 million years, and the present. And why couldn't that have said 2,000 years ago? And 1,350 years ago? And 650 years ago? And the present. You say, well, because it's moving, it's not moving. Okay, so it was moving faster at the beginning, now it's moving slower. But what? Was the earth smaller and it keeps expanding? Or are these land masses just moving around? And was anyone here 200 million years ago to measure? So this is all theory. So just recognize that they enjoy having huge, large numbers because it gives you a sense of it's going to be okay. The sun is burning up, right? But relax. It's not going to burn up for 2 billion years. So you don't need to worry about it. So you understand? Long periods of time are a way for mankind to put his mind at ease about what's going to happen. And I'm thinking 2 billion years, well, let's see, if 6,000 years ago or 8 or 10,000 years ago, God made this earth, and if he, about 2,000 years ago, sent his son to die on a cross, who knows, it could be in another 1,000 years or even 1,000 hours, he'll decide that he's finished with this program. Have any of you read what he's going to do in Revelation? This earth is going to be destroyed, and there's going to be a new heaven and a new earth. And those of us who are believers in Jesus Christ as our Lord and Savior, probably should be as our Savior and Lord, because he saved us, and then we submit to his leadership in our life as the Lord of our lives. We're going to live in the New Jerusalem. If you haven't read that yet, you ought to read it. It'll put your mind at ease. But and page 91 shows a picture of what's going on underneath. According to theorists, this is what they theorize about. And again, it says on page 91 that seismographs and seismic waves are used to determine some of this stuff that's going on down underneath the earth. Have any of you been close enough to see a volcano? I haven't either. I've seen pictures of what happens, and it's pretty phenomenal. Page 92 shows pictures of those plates and where they crash into each other. The bottom picture shows where the motion of these plates causes earthquakes. So if you want to live in a high earthquake zone just so you can see what it feels like, where would you move to? Alaska? California? The west coast of Central or South America? Whoa! And a whole bunch of islands north of Australia. Personally, I like living here in the Midwest, so I'll just get on Google and look at pictures of all that stuff. And it's pretty cool, some of the pictures you can see. On page 93, it talks about different kinds of volcanoes and how this stuff just comes oozing up out of the ground. Something cracks, and so there must be pressure as well as all that heat underneath there that pushes this stuff up. Because when you see, when you saw that volcano in Hawaii exploding, I mean, there was enough pressure where it was throwing huge volumes of stuff way up into the air. So you know that there's a lot of pressure down inside the earth that's forcing that stuff up. There's a picture on page 94 of an undersea volcano. I actually saw a picture. I was doing some looking for volcanoes one time on the internet, and here were some guys out in their little boat oaring around, and all of a sudden the water starts bubbling, and they go, "Oh, what is that?" And the next thing it's whoof, and an undersea volcano was erupting, and they just happened to be close enough to get a picture of it. But if the guys who got this picture were any closer, you wouldn't see a picture. You would see a missing persons report. And somebody's trying to find those folks who disappeared out there when that undersea volcano erupted. On page 95, it talks about rock formations. Have any of you studied rocks? So what kind of rocks are there?
Lots.
Igneous, sedimentary, metamorphic. What is that all about? I'm thinking that we probably ought to look at my rock collection. Maybe we should read page 95. Minerals. Yeah. Page 96. I don't know where to set this back here so you can all see it. So I'll just put it right here. And then turn it where it doesn't get knocked off. So everybody gets a chance to come up here and just look at all my cool little rocks.
Which one's from the core?
And if you want to know what something is, there's shows you what it is. If you see a number and you go, "What is that?" You can look at that little sheet of paper.
What's number 33?
Sulfur.
I wish I could say I went out and collected all these rocks and labeled them, but I didn't.
That would be a fun job.
Do you have any from the core?
No. I just went to a website on the internet where they sell this stuff and go, "Whoa, isn't that cool to see all those different kinds?" And I'm not sure that it's like we need to memorize a whole bunch of categories of rocks. Just look at them, enjoy them, and appreciate what God has done. I mean, is it fair to say that God has made a beautiful world? You look outside and see spring coming and the trees are getting gold. When I was in Colorado, I bought some real gold.
Really?
Yeah,
These three
you
go.
can buy it. What?
Where'd these three go?
That was the real gold this time.
I don't know. Someone took them. What were those? Are they on the?
This one's
Do they have a number on it?
75, 76, 77.
No, you're 75.
Oh,
There we go.
in the wrong spot. It only goes up to 75.
Okay.
So we're just in
that's
the wrong
why.
spots.
So there's just some that were in the wrong spot.
And those are just random ones, I guess, that are in there.
Because it
Looks
has a
like
number.
a magnet.
You're so cool. Shlomo, you want to give me one of these for a good day?
Have any of you had any personal experience with rocks, collecting rocks, or working with rocks?
I used to.
What have you done with them?
I collect rocks. I really enjoy it.
And do you tumble them and polish them? They are so beautiful too, aren't
I
they?
love
I mean,
going and like finding them like
it's
in the
like
mountains
some
and
little
stuff.
rock that just doesn't look like much.
Mm-hmm.
Once you put it in your tumbler and let it
Exactly.
run for a few days, and it
Yeah.
polishes it, it's like it's got beautiful colors. Who else raised their hand? What have you done
I
with rocks?
did. I collected
See?
flint and steel. Like,
Oh, what?
so
see.
I tried to make fire when I was little, so I
Nice.
collected a bunch of those.
You know
We
what?
need more to go to the
Okay,
end of the world.
when my
Oh my God.
when my grandkids were little, I took them out to a place in Oak Grove where they were having a nap in. Not NAP, but KNAP,
Oh, I was really confused.
where they take flint and
Flint
they
steel with
they
consider-
cook it to get it real hot to make it brittle,
Drake's having a really good
and then
time.
they chip off pieces of it
Minecraft.
and make arrowheads.
This is the weakest
Oh,
one.
that's cool.
And I took my grandkids out there so they could see,
Why don't you have any diamonds in
and there are guys out there who actually
Kidding.
cut down limbs and make their own bows and arrows and make their own arrowheads and then go out in the woods and shoot deer in Missouri, just like Native Americans used to do. And I was so intrigued with this, I bought a bucket of rocks and then was going to teach my grandchildren how to make arrowheads. And the way you make arrowheads, the way Native Americans did, was they used the tips of deer antlers. Well, my son-in-law hunts deer all the time, so he had all these antlers. So I took some of the antlers and sawed off some of the tips and used those. And sure enough, you can take a deer antler and hold this rock and chip on it and make it and chip it to shape and make a sharp edge and turn it into an arrowhead. But it takes forever. And then you think you have one almost made, and then it breaks. You have to start all over again. So I got on the internet and found a place in Mexico where they were selling arrowheads in big plastic bags, and I bought about 30 of them. And so then I took them to a family reunion in Oklahoma, and I set up a table with this arrowhead making thing. And my sister came by and said, "What is this, Tom?" And I said, "This is for the kids to learn how to make arrowheads like Native Americans did in early Oklahoma." And she goes, "Oh, you can't." I said, "Well, look at all these that I made." And she goes, "You made those?" And my sister's gullible, so she swallowed that stuff. And I said, "Well, what do you think?" I mean, I didn't say, "Yes, I did." That would not be true. I said, "Well, what do you think? Where else would I get them?" And my little brother goes, "Well, it says on the back, made in Mexico. I think that's where you got them." But all these little kids, I had them with goggles and gloves and chipping on these rocks to try to turn them into arrowheads just to see how hard it was. And see, here's the thing. Early Americans, when they settled this country, Europeans, when they came here and they met Native Americans, do any of you know what they labeled that group of people?
Pilgrims?
Savages. Savages. Why were they calling, and I thought, why are they calling these intelligent people who, see, okay, I lived in Oklahoma. I grew up in Oklahoma. In Oklahoma, to graduate from high school, in Missouri, to graduate from high school, don't you have to pass a Constitution test?
What?
Okay, it used to be, you had to pass a test
from
over the
Arkansas.
Constitution. In Oklahoma, when I went to high school, you couldn't get a high school diploma without passing a test over the 5 civilized tribes. And I was immersed in information about 5 Native American tribes who had advanced civilizations before the Europeans arrived. But when the Europeans got here and saw the way they lived, they said they're savages. Part of it was because they didn't have a home that they stayed in. Their home moved from place to place, following the buffalo as a part of their livelihood. What would Europeans who settled here have called Abraham, Isaac, and Moses?
Savages.
Savages, because they lived out of tents. Because they didn't live the way Europeans lived, they concluded they were savages and had to be civilized. And in the process of trying to civilize these Native Americans, who were very intelligent people with a very advanced civilization, they brought with them all of their European diseases, and I'm going to say millions of them died from contact with Europeans. And the Europeans didn't even realize that they were doing that. So have any of you read about this guy who was, a glacier was melting in Switzerland, and they found this guy who had died on the mountain and been buried for years, and he's about 2,000 years old?
Whoa.
I think so.
Yeah, I think
Never heard of it.
Never heard.
They're studying his body, his life, and the stuff he had with him, and he had insulation in his shoes, and he came from a very advanced civilization, but historians say, but that can't be, because that long ago, man wasn't that civilized. We've only been civilized for a few years. The people who say that just don't realize how civilized they were in the Garden of Eden. And granted, when they got kicked out of the garden, things kind of fell apart, and people did some pretty uncivilized things, but there were some pretty civilized things going on long before Europeans started trying to fix the world. And when I say Europeans, I'm talking about my ancestors, because my ancestors were all European. English, French, German. Let's see, is that all of them? I think so. English, French, German, Bohemian. What else? And then my sister says, and Native American, Tom. I'm going, no, I do genealogical research. There are no Native Americans in our ancestry. Yes, there are. You know why people in Oklahoma want to find Native American ancestors?
Because you get benefits.
If you have enough Native American blood in your system, you get some super benefits from the tribal councils. So people want to cash in on the benefits. Actually, in my genealogical research, had an ancestor who tried to cash in on, because one of his ancestors had married a Native American, but it was too far back for him to get the benefits. Page 97 talks about slopes and streams. Have any of you seen how huge the Missouri River is now? I went to Parkville over spring break to watch my grandson play baseball. And my wife says, Highway 9 is closed. How are you going to get there? And I said, Highway 9? She goes, but it's closed. I said, oh, they say it's closed, but I want to see what the river looks like. And by the day we drove up there, half of Highway 9 was closed. The half coming back from Parkville, but not the half going to Parkville. And so we're driving along, and off to the left, you see the Missouri River, which is running over its banks, flooding parks, clear up to just a few feet away from the railroad tracks. And it's just like covering all that land out there. It's just like, whoa, this river is really flooding. But it's even worse upstream in St. Joe. It made me want to drive up to St. Joe and look at it. And then I thought, no, I better pass that up. Go home and Google it and look at some pictures. Did any of you drive someplace to see that, what was that thing we had last summer? The solar eclipse?
Mm.
Oh, we saw it in our backyard.
Did any of you go someplace to watch it?
Yeah.
I drove way up north, looking for the perfect spot to watch it, parked my car, here it comes, and the clouds come rolling in and block the whole thing. Bummer. My daughter drives to North Kansas City. She's running late, so she pulls off in a parking lot of the shopping center, and voila! No clouds, it unfolds in front of her. Man, what kind of deal is this? I still haven't seen a solar eclipse in its entirety. I mean, I bought those little glasses for everybody. And some people looked at it without glasses.
That's dangerous. They have the high school and the middle school in our district watch the solar eclipse with no glasses.
And now some of those kids are having vision problems. That stuff will mess your eyes up. Page
Solar
97,
glasses.
under slopes and streams. Page 97 talks about weathering. Weathering, what would that be? Have you ever seen erosion? Have you ever seen water running down somewhere and then it runs in the same spot so often that it cuts a little slot in the grass and makes a little ditch, and you have to go fill it in, and then next year it does the same thing again and keeps washing the dirt away? Well, that's basically what's going on with weathering. And it's actually the water coming from the sky and hitting things and slowly breaking it up in pieces. You go, how can the water break up rocks? Okay, the rocks have cracks in them. The water gets in the crack. Then when the water freezes, what does water do when it freezes?
Expand.
Have any of you ever had a bottle of water in your car that froze in the wintertime and it puffs out? Well, if it was in a glass jar instead of a plastic bottle that would expand, what would happen? Anyone know what happens in a glass jar when one of these glass pop bottles with a little metal cap on it? Anyone know what happens when one of those freezes in the wintertime?
Breaks.
It pops the cap off the top and comes oozing out of the bottle. Plastic bottles will stretch, so they'll stay together. But if you didn't have that top that would pop off, it would break the bottle. If you had some screw-on tight lid that wouldn't give way, like a jar of fruit or something, and you put it outside, if your parents can stuff, if you put that outside in the wintertime, say, let's see what happens to this can of green beans. And your mom says, no, it'll break the jar. Say, I don't like green beans anyway, so let's put it out there and do an experiment. And then watch it break the green bean jar, and the green beans are frozen, but the jar is not usable after that. So weathering just from water, it's amazing how much water can affect things. Well, okay, you polish rocks, you said. Okay, have you ever been to Colorado?
Yes.
Where you can go down in a stream and pick up some little polished rocks? You go, whoa, did someone who has a polisher polish this and then they dropped it in the water? How did that little rock get polished like that?
The water tossed it over.
The water tumbles it around, and through the tumbling and interaction with other rocks, it polishes it and makes some beautiful stones, doesn't it? That you can pick up in Colorado. That's another thing. When I travel, I see a beautiful rock by the side of the road. I pull over. By the time I get home, I have the back of my car full of little rocks. And I said to my wife, put them out in a rock garden by our house, then we'll have little remembrances of all the trips we've made. So she does, and now I go out and look at them, and I can't remember which rock came from where. But they're still pretty. They can also be broken down by chemical weathering when they're exposed to air and water. Acids released by decaying vegetation also weather rocks. Page 98, mechanical weathering. Rocks are broken down by physical force. They expand and contract with frequent changes in temperature, and this action causes them to break apart. Rainwater seeps into roadway cracks and freezes into ice crystals. When the temperature turns colder, yeah, you know what those are called all over Kansas City? What do we call them? Potholes. Have you seen a road crew out somewhere filling up a big pothole with this black asphalt stuff? In the dead of winter, they were filling one up here on County Line Road. I was impressed that Belton was down there doing that. Well, what's happened?
It's back.
It's back, and it'll be back until this summer when it quits freezing and it quits messing that stuff up, and they can put some stuff in there that'll be more permanent. But I say permanent, nothing's really permanent because of this erosion process. that things just keep breaking down. It's I guess it's what they call the law of entropy. Things just fall apart and come apart and wear out. I get a pair of shoes that I really think are cool. So what happens if I wear them very often? You don't know. You've never worn a pair of shoes that long?
Oh, mine have holes in them.
It wears them out. And then I go looking for another pair like them and I can't find them. So sad. They don't make them anymore, they say. Rainwater seeps into roadway cracks and freezes. The water expands about 9% when frozen. Have any of you ever looked when you cross over a bridge and noticed that there's a crack in the road on the bridge? Have you ever noticed in the summertime that the wires between, electric wires between poles has a big dip in it?
Mm-hmm.
And in the wintertime it's almost straight? See, this stuff happens so slowly, we often don't notice it. But this expansion and contraction stuff that goes on around you in the world, it's just part of the process of going through these seasons. Plant roots grow into cracks between rocks. Now, you've seen some of this. Driving down the highway in Missouri, you'll see like a rocky, where they dug the road down. So here's this big cliff with just rocks, and here's a little cedar tree growing out of the side of the rock. And it just keeps growing and growing and growing and getting bigger and bigger and bigger. And pretty soon, when this tree is about 10 feet tall, if you drive down that same road and keep an eye on it, you'll probably see that tree laying down eventually, because what happens is it breaks the rocks up, comes loose and falls down to the ground, and that tree's gone. But it's okay, there's another one growing somewhere. And are you interested in knowing how all those cedar trees got planted all over those rocks?
Mm-hmm.
Or do you know? My wife says TMI. Too much information. Little evergreen trees have little berries on them that birds love to eat. So they eat the berries and pass the seeds through their body onto the ground wherever they were sitting when they ate the berry. And where the seed lands, if the sun and water hits it just right, it'll sprout and start growing another tree. So now you know where the birds land to eat their fruit, because you find where the birds are planting trees all over the country. I think that's kind of cool. But my wife says TMI, TMI, too much information. On page 98 it talks about mass movement. Well, it shows this soil creep. That is a mass of soil that's creeping down a hill. But have any of you ever seen a mass of soil creep down a hill real fast? It's called a landslide. The land breaks loose and slides down the hill. And there have been some huge landslides that have caused all kinds of devastation around the world. If you want to see pictures of them, you just go to Google and type in landslides. And then you can click on them, and sometimes you can actually see them happening. Where some guy's with a camera watching, and there was a little landslide, so they stopped traffic, and he's watching thinking maybe there'll be a bigger one, and about that time, a whole big side of the mountain breaks loose, and you see it getting closer and closer to the camera, and then you see the camera jugging where he's obviously running away from the landslide. And after he gets away and the dust clears, he turns back and shows some more of the picture. I'm going, now there's a guy who got a little bit too close to that one. Page 99 talks about stream drainage. Have any of you ever walked in a dry creek bed? Or have you walked through a stream bed that didn't have any water in it? Down behind our house, in a neighbor's pasture, is a stream bed that if you walk down the bottom of it, it's probably as wide as this room, and when you're in the middle of it, down underneath, the edges are up above my head. But there's no water in it. So one day we had a big rainstorm, and my grandchildren were over at my house. This is when they were little. And I said, grandkids, I want to show you something. And I had them put on their raincoats, and we walked down into the neighbor's pasture, and we're standing there under a tree where the rain wasn't hitting us very much, and we're watching the water from upstream just keep getting higher and higher and higher, and pretty soon this little stream that's normally empty was full of water clear up to about my chest, just running downstream. Where was it going? You go, oh, where was it going? Well, maybe I should show you something about where this stuff goes. Oh no, I'll have to wait and do this tomorrow. I mean on Wednesday. Yeah, we're out of time.
Today's Wednesday.
Oh, on Friday. I'm sorry, I can't give you my... Where's this water going? It's going downstream into the Little Blue River, down into the Missouri River, over to the Mississippi River, down to the Gulf of Mexico. And if you don't believe that, then take a little bottle and put a note in it. This bottle was dropped in the stream in Raymore, Missouri. If you find it in the Gulf of Mexico, would you please call me at this number?
So you get charged for littering.
Yeah, you get charged for littering. That's exactly right.
Please for my college tuition.
All right. See you on Friday.